Okay, so now this is how we draw the Lewis structure for the aluminum. Yeah. Again. Now next one, how about the nitrogen? Nitrogen is in the 5A group. So this guy has a 5 valence electrons. Okay, this guy has 5 valence electrons, which means we need to draw 5 dots around it. We need to draw 5 dots. So again, you're gonna draw 1 dot on each side. And then we have extra 1 more dots to draw. Then you need to choose one of the electrons and make this as a paired electrons. Okay, yeah. So it doesn't matter which dots you're gonna pair. As long as you pair one of the dots, then that's gonna be the Lewis structure. Okay, so in this case, you will see the nitrogen has 3 single dots and 1 paired electrons. So this one is a paired electron, and we call it a special name. It's called a lone pair. Those guys is a lone pair. The reason it's called a lone pair, which means as long as the electron is being paired, then they are just isolated from other electrons. Okay, they're not going to do anything. They're just a pair. Okay, so paired electrons, those are stable electrons. And those are called a lone pair. The rest of the others are single electrons. And a single electrons is really, really active. And those single electrons, actually, they are actively to try to find a pair. Okay, I'm not sure. I mean, you're eagerly to find up your pair or not. Okay, but the electrons is going to eagerly to find a pair. So that's why they need to do the chemical reactions. They try to pair it with others to make a compound. Okay, so they try to pair it with others to make a compound. This is what we do. All right, so now go ahead to figure out what is the valence electron for chlorine. Okay, what is the valence? What is the Lewis structure for chlorine? And what is the Lewis structure for oxygen atom? What is the Lewis structure for chlorine? And what is the Lewis structure for oxygen? Chlorine has 7 valence electrons, since this guy is a 7A group, right? And then you first assign 1 dot on each side, and they have 3 to go. So you should have 3 side as a paired electrons, that's a lone pairs, and 1 side has a single electrons. Okay, so this is a chlorine. For oxygen, they have a 6 valence electron. So this guy should has a 2 side got paired and 2 side got single. Okay, well, for the oxygen, doesn't matter how you draw. You can draw like this. This is totally fine. Okay, doesn't matter how you draw. This is how you draw the electron Lewis structure for the valence electrons. Okay, a Lewis structure for elements. Okay. All right. So the next part, we're going to talk about the compound. So those are the elements, and we talk about the Lewis structure for compound. Lewis structure for the ionic compounds. Okay, so first of all, we're talking about ionic compounds. All right, and then let's first give you one example. Okay, we know the sodium chloride is ionic compound. Metal first, non-metal later. Okay, so let's see why. Okay, so now sodium has 1 dot. Chlorine has 7 dots in the outside. Okay, one day the chlorine is meet with the sodium on the street. They suddenly see each other, and then the chlorine said, "Hey, sodium, I wanted your dots. Can I give you the dots?" Well, sodium is really weak. It said, "Oh, no problem. Okay, I give to you." So, and well, the sodium is willing to give the dots to the chlorine because they really want to lose the dots. Okay, so now what happened is the sodium is completely lose the 1 dots, and the chlorine is completely gain these dots. So when the sodium completely losing the dots, what happened? Since the dots is an electron, they're losing one of the electrons. So the sodium make it itself as a positive charge. But for the chlorine originally in the outside, they have 7 dots. But since they gain 1 dots coming from the chlorine, coming from the sodium, so they are gaining 8 dots. They completely got 8 dots. Okay, and in this case, they have 1 negative charge. Originally, they have 7 dots and they have a 0 charge, and they gain 1 electrons, so they become 1 negative charge. And this is actually a perfect couple to each other's, because sodium, they would like to lose 1 electron, and the chlorine would like to gain electrons. Okay, yeah, and why they do? Because the 8 numbers, you see, the 8 numbers is a magic number in chemistry. 8 number is a magic number in chemistry. If you see, you have the 8 of the dots in the outside for these elements. The elements is the most stable form. It's the most stable form. All the elements, doesn't matter what kind of elements, they always try to have 7 electrons in the outside. 8 electrons in the outside to make it stable. So this is a very, very important part. Okay, so that is why some of the elements, they eagerly to try to gain the electrons. Some of the elements eagerly try to lose the electrons. They just try to have 8 electrons in the outside and try to be stable. That's it. Okay, yeah. So the chlorine gain 1 of the electrons, and then they are going to have 1 negative charge over here. Sodium losing 1 of the electrons. Then you can see sodium is a 1s2, 2s2, 2p6, and 3s1. So they're going to losing the 1 electrons in the outermost shell, and inside they're still going to have 8 electrons as a stable form. Okay, so that is why sodium, they prefer losing the electrons. Then when they lose the electrons, they will be stable. But the chlorine, they prefer gain 1 more electrons, so they will be stable. That's it. Okay, yeah. So this is what happened for the ionic compound. One is completely losing the electrons, one completely gain the electrons to make this stable. And the reason the chlorine would like to have a hard bracket over here is try to separate the charge with the dots. So if you draw in the future, if you draw some of the Lewis structure, they have a dots inside, and you have to making the using the hard bracket to write the charge in the outside of the bracket. Okay, yeah. The reason for this rule is happened in like 50 or even 60 years ago. I mean, even longer. There's no printer up there. There's no computer up there. Everything is written by handwriting. So some of the scientists really had a bad handwriting. Okay, yeah. So if you do not have the bracket, the people just draw something like that. You really hard for you to see whether this is charge or dot. Okay, yeah. So that is why the people making the rule. Okay, how about let's just making the bracket and put the charge outside. So at least you will see that is a charge. That's not a dot. Okay, so this is what happened for the hard bracket. Okay, yeah. So make sure when you write the charge, you're gonna have the hard bracket. But for sodium, they don't have because there's no such dots in the outside of sodium. That makes sense, right? There's no such dots, so you don't have to draw the bracket for sodium, but you have to draw the bracket for the chlorine side. Make sense? Okay. Okay, so this is the ionic Lewis structure for ionic compound is not very important. Okay, the most important part is to draw the Lewis structure for molecular compound. Okay, so let's take a break and then we will talk about this. All right, so let's come back. Okay. The next part, we're going to talk about the most important part for the Lewis structure, which is the molecular compound. Okay, Lewis structure for the molecular compound. Okay, so give you one example, like a hydrogen. You see, hydrogen. So hydrogen has a one valence electron. This hydrogen also has a one valence electron. So one day, those two hydrogens, they meet on the street, and one of the hydrogens said, "Hey, bro, how are you doing?" "I'm doing good." Okay. So I want one dots and make me stable. Can you give me one of the dots? Well, this hydrogen said, no way. Yeah, I also want one of the dots. I'm not going to give to you. You're give to me. That makes sense. Well, so they're going to fight to each other. Okay. They try to be stable, but they want to grab the one of the dots from the other. But the point is, the hydrogen are all the same. Both of them are identical. Those are the same atoms. None of them going to have the force to grab the electrons from the other one. So both of them want to be stable, and both of them don't have the force to force the other one to release the electrons. Then what happens? So they have to sit down to have a conversation. Okay, yeah. So the hydrogen, then they have a very good idea. So this hydrogen said, how about I give out one of the dots, and you also give out one of the dots, and then we're going to, and those two dots is not going to belong to you, and it's not going to belong to me. It's going to belong to us. Okay, so they're going to share the electrons instead of completely grabbing the electrons from another one. Okay, so this is what happened in nature. They are sharing the electrons. Animals, they know how to share. Okay, and our parents know they want us to share. But think about how many times you fight with your sibling just for things. Okay. Okay, so this has happened in every family. Me too. Okay. So these two electrons is not just going to belong to this hydrogen, and this electrons is also not going to belong to this hydrogen. They're sharing those electrons. So this is the sharing electrons. Those two electrons is not just going to one of the hydrogen. They're going to, they are orbit around the two hydrogens. So those are the sharing parts. And when we draw the Lewis structure, what happened? We're going to draw the shared electrons as a bond because there actually is a making bond. Those shared electrons is making a bond between those two atoms. Okay, so the sharing electrons actually is a link between those two. Okay, it's a link between those two atoms. They are sharing to each other's. And we give it this bond, one of the name is called a covalent bond. This is called a covalent bond. So that is why the molecular compound is also given another name. It's called a covalent compound. It's the same thing, okay? Molecular compound is also called a covalent compound. It's because they have a covalent bond, and those bond is a shared electrons, okay? It's a shared electrons. All right. So those shared electrons is not just happen between the two of the hydrogen. Well, so give you one example. So that is why when you draw the hydrogen gas, it's not just H, it's H2, because those two will combine together to making a molecule, okay? And for the Cl and the Cl, they're doing the same thing. Chlorine, we know this. You see, each of the chlorine only have one single unpaired electrons. So one of each of them would like to eagerly grab one electrons from somebody. Okay, so those two chlorine, they're both equal, so they have to sit down to share those two electrons. So then each of them, they will have the 8 electrons, make them stable. So that is why, again, if you draw the Lewis structure for the chlorine, then you're gonna draw like this. Okay, don't forget you have a dots on the outside. And this is the Lewis structure for chlorine gas. And we talk about chlorine gas, it's not just the chlorine, it's not a Cl, it's a Cl2 because they have a 2 chlorine over there. Okay, yeah. And what happened for the for oxygen? Okay, and we know oxygen has 6 dots, 6 valence electrons. This oxygen also has 6 valence electrons. Then what happened? You see, those guys has each of this oxygen has 2 unpaired electrons. Then what happened? They want to pair those 2 unpaired electrons. So then what happened? For this guy, each of them will going to give out 2 electrons, making 2 paired shared electrons. This guy will going to have the 2 paired shared electrons, and those 2 paired shared electrons will making a 2 bonds over here. Okay, we're making 2 bonds. So in another word, 1 paired shared electron making 1 bond, 2 paired shared electrons making 2 bonds. So that is why when we write oxygen gas, what do we write? We write O2, not just O, since they have to combine another oxygen making a stable form. Only single oxygen atom doesn't work. It's not stable. They have to react with other stuff to making 8 electrons in the outside. And one more thing, then let's see how about the nitrogen. This is one nitrogen, and this is another nitrogen. Well, based on the previous knowledge, then you can think about each of the nitrogen has 3 single unpaired dots. Then what happened for those nitrogen? They try to bond with another things to making 8 electrons. So each of those nitrogen, they're going to give away the 3 electrons, and then they're going to have 3 paired electrons. They're going to have 3 paired electrons, and those 3 paired electrons will making 3 bonds. But in this case, each of the nitrogen will have 8 electrons. You see, this is 6 plus 2, that's 8. This is 6 plus this 2, also 8. So now, in this case, this nitrogen will making a triple bonds. And then nitrogen gas is N2, not just the N. Okay, yeah. So if you look at this, the one of the dash is called a single bond. 2 of the dash is a double bond. And 3 of the dash is the triple bond. Okay, so in the molecular compound, sometimes you will see single bonds, sometimes you see double bonds, sometimes you see triple bonds. Okay, but most of the cases you will see single bonds. Okay, most of the cases you will see single bonds. You shouldn't see double bonds and triple bonds too often. Okay, yeah, most of the case is a single bonds. Okay, so this is the Lewis structures for the molecular compounds. We'll have the compounds like this. You will see single bonds, double bonds, and triple bonds. Okay, yeah. All right, so any questions? And so that is why here we talk about, we have at the very beginning of the class, we talk about there are 2 different compounds, right? One is called the ionic compound. One is called the molecular compound. So now I hope you understand the difference between those 2. Ionic compound, the reason it's called ionic because one of the elements in there losing the electrons, and they are the one completely gain the electrons. So those 2 particles has a charge, and those are the electron attraction between the positive charge and the negative charge, making their bonds. And this is called ionic bond. But for some of the molecular compounds, they're not going to gain or lose electrons. They're sharing the electrons, right? Yeah. So once they share the electrons, they no charge. So we're not going to call them as ionic because there's no ions over there. They're sharing the electron, and they shared as the covalent bond over there. So that's why we give its name as a covalent compound. That's why. Okay. Yeah. So okay. So the next part we're going to talk about. Okay. So if I give you the molecular compound, just give you the formula. How can you, based on the formula, to figure out the Lewis structure? Okay, draw the Lewis structure based on the formula. Okay, so we're going to draw the Lewis structure based on the molecular formula. You draw the Lewis structure based on the formula. So first of all, let's just look at the very simple one. I mean, CH4. This is a methane. Okay, this is a methane. So if you want to draw the Lewis structure for methane, you need to identify in this methane, there's 2 elements over here. You need to identify, okay, which one is a central atom, which one is a side atom. If you look at, there's only just this carbon here, only just 1 carbon, but you have a 4 hydrogen, and those are 1, the elements only have 1. It's called a central atom, which means this atom will be in the central of those structure. Okay, hydrogen has 4 of them, and we call this is a side atoms. Central atom and side atoms. Okay, so when you recognize this, and you will know, okay, so when we draw this, we need to you need to draw a big structure. You put a carbon, which is a central atom, in the center, and then you're going to put the hydrogen on the side. Okay, since we have 4 of the hydrogen, so you put 4 of the hydrogen on the side. Okay, yeah. And the next part is you need to count how many valence electrons in total for those elements, for those compounds. How many valence electrons for the whole compound? How do we count the valence electrons? You need to count how many valence electrons for the carbon and how many valence electrons for the hydrogen. And so for carbon is a 4A group. So this guy has a 4 valence electron for carbon. And hydrogen, this is in the 1A group. So this guy has 1 valence electrons, but they have a 4 of the hydrogen. So you're gonna time 4. So you will see 4 plus 1 times 4, totally, this guy has 8 valence electrons. So methane has 8 valence electrons, okay? Methane has 8 valence electrons, and then that means 8 valence electron means you gotta write 8 dots, okay? So in this whole compound, you have to draw 8 dots, okay? And another thing is, in most of the cases, the valence electrons for a compound should be an even number. Okay, in most of the cases, the valence electron for a compound should be an even number. Okay, should be an even number. All right, then let's see. You need to draw 8 dots. Then let's see how do we do this. First of all, you need to, since this guy has, we have a carbon has hydrogen, between and carbon and hydrogen, they should have a shared electron, right? Otherwise, they cannot making a bond. So you're gonna write the 1 pair of the shared electrons between each of the atoms, right? You draw the shared electrons between each of the atoms. This is the beginning. And then if you have an extra, then you can assign more dots. But obviously, we already assigned 8 dots now. Okay, we already assigned 8 dots. So in this case, you're not going to assign any more dots. And then we need to double check whether this molecule, this Lewis structure is correct or not. How to check? We need to base on 2 rules. One is called the duet rule. One is called the octet rule. So what does that mean, duet? Duet is only for hydrogen and helium, which means for hydrogen and helium, which is the 1A group, the first row, first period elements, they only have 2 electrons, right? It's only just has 1s orbital. 1s orbital only have 2 electrons. As long as those guys has 2 electrons, then they will be stable. Okay, as long as they have 2 electrons, they will be stable. Okay, so for example, this guy, hydrogen over here, they already have 2 electrons, so this guy is stable. This hydrogen also has 2. This guy has 2. This guy has 2. So each of the hydrogen is stable because they follow all duet. They only need 2 electrons. That's the maximum for hydrogen. Octet rule, that means for the rest of the others, rest of other elements, they must follow 8 electrons outside, which means those guys have to have 8 electrons in the outside. They have to have 8 electrons in the outside. Okay, so hydrogen, in this case, is carbon have to follow octet rule, which means in the outside of the carbon, they should have 8 electrons. So if you count, obviously, they have 8 electrons. That makes sense, right? So now in this case, hydrogen follow duet, carbon follow octet, then that's gonna be a perfect Lewis structure over here. And then which means this Lewis structure will be correct. Then what are you gonna do? You're going to remove those shared electrons and write a single dash to making a bond. And then this is the Lewis structure for methane, CH4. Okay, this is the Lewis structure for methane, CH4. Okay, so let's see, let's talk about another example, CCl4. Okay, CCl4. This one, again, CCl4, you're gonna look at this compound. This is called a carbon tetrachloride. You probably don't know what is this name, the name for this compound, but you should know the nickname of this compound. Freon. Have you heard of freon? Right? So that is the freon. CCl4. That's a freon. Okay, so if you want to draw the Lewis structure for the CCl4, then again, carbon here, you recognize is central atom. Chlorine here is a side atom. So you're gonna put the carbon in the middle and the chlorine on the side. Okay, so that is the structure. And then you're gonna count how many valence electrons this guy has. Carbon, again, carbon has a 4 valence electron plus chlorine. Chlorine has a 7 valence electron because this guy in 7A. And then you multiply by 4. And then you can see how many you have. 28 plus 4, they have 32. So totally, this guy has 32 valence electrons. Again, remember, we talk about most of the cases, the valence electrons should be even number. Okay, the valence electron should be even number. So 32 means for this Lewis structure, you're gonna assign 32 dots. No more, no less. Okay, you have to assign 32 dots over here. Then what are we gonna do? First of all, we need to draw the dots between each of the electrons, right? Between each of the elements. So this guy has 2 dots shared. This guy has 2 dots shared. This guy has 2 dots shared. And this guy has 2 dots shared. Okay. So now, first we draw those each of the dots, the pair, one pair of the dots between the compounds. And then if we have more, we're going to assign more dots. Now we only assign 8 dots. Now we have 32. So we still have a lot to go. In the next part, you're going to fill the electrons around each of those elements. And remember, except hydrogen and helium, you're gonna assign 8 electrons around those elements, okay? And very, very important here, okay, listen to me, very important. When you assign the rest of the dots, we always assign the paired dots for a compound, okay? We always assign paired dots for a compound. Okay, the reason you have a compound is because all those electrons should be always paired. All the electrons are paired. So that is why when we assign the rest of the dots, we're going to assign the paired dots, not a single dots, okay? So now we have 8, we have a go to 32. So now 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Okay, so now we assign the 32, right? Because this guy needs 32. So we shouldn't assign more than 32 over here, okay? So 32 dots, we already assigned. Then we need to double check, okay, is this correct structure? For each of the chlorine, yes, they have 8 electrons. For the central carbon, yes, they have 8 electrons. So all of the elements follow the octet rule. So that's perfect. Then what are you gonna do? You're going to remove those shared electrons and write a bond, single bond. So that is the Lewis structure for CCl4. I saw a lot of people, they write the CCl4 like this. This is completely not correct, okay? Because you're just writing the 4 dots over here, which is the 8 dots, 4 bonds. But you ignore all the dots around the chlorine. Okay, so obviously this is not correct Lewis structure for chlorines, for CCl4, okay? You have to assign the exact number of the dots. Doesn't matter the dots is in the bond or the dots is around the elements, but you have to put the 32 dots over there. Are you clear? Okay. Okay, so yes.
Can I show you something? I want to show you something.
Later, okay, when we take a break.
It's about this.
Okay, yeah. So what's,
Is this the same?
what do you mean? What do you mean it's the same? You talk about this one? So again, this, if you just draw this, this is the chlorine elements, chlorine atom, okay? And if you draw this, this is the chlorine that combined with the carbon, okay? This is a compound, this is just elements.
Can you use
Doesn't matter. I said it doesn't matter where the single dots it is. You can put the single dots over here. You can put a single dots over there. It doesn't matter. As long as this guy has 7 dots for the one of the atoms, then that's good.
that's what I'm talking?
Then what are you talking about?
Can you replace the double dots with this thing?
No. Oh, okay. So what the Comenia talking about is, can we replace those lone pairs with the dash? The answer is no. Okay. The reason we're drawing the dash means a bond. Where those guys can making bond. The bond have to be shared electrons. I mean, is those 2 dots shared with something? No, right? They have to share it with one of the other elements. So those guys cannot write in a dash. You have to write the dash between 2 of the elements. Those guys is shared electrons, but those electrons is not shared electron. Those are lone pairs. Electron lone pairs is not shared electrons, not shared. Does make sense, Comenia? Is this what you are asking? No?
No.
No, what is your what? So are you talking about your, can you draw this?
The dots, because we learned.
No, you can't. I just let you know the dash is only in the bond. You cannot draw the dash like this, okay? This means a bond. The dash means a bond. You cannot write the dash. You have to write the single dots. Okay? Yeah.
Okay.
Yeah.
My whole life we did that.
Sorry, yeah, we're not accepted this way. Okay, we cannot accept this way. You have to separate the dash with and the pair. Those pair means is a lone pair. It's not react with others. Only the paired electrons with other things can be rewrite as a dash. Okay. Okay, so let's do one more practice over here. How about the water? Okay, so again, if you look at the water, you're gonna recognize which one is a central atom. Obviously, oxygen is a central atom. Hydrogen is a side atom. So you put oxygen in the middle and put the hydrogen on the side. Okay, yeah, and then you're gonna recognize. Okay, so in this case, how many valence electron for the whole compound? Okay, so hydrogen has 1, your time 2, and plus oxygen. Oxygen valence electron, oxygen is 6a, so they have a 6 valence electron. So totally they have 8 valence electrons. So we have to draw the 8 dots over here. So first of all, you're gonna draw a parity electrons between each of the atoms. Then we got a 4. Then we still have a 4 more dots to go. Where are those 4 more dots to go? I strongly recommend you go with the central atom first. So please fill the central atom first. And if you have a more, you go to the others, okay? Fill the central atom first. So in this case, you're gonna put 4 more over here, then the central atom has 8 electrons. Follow the octet rule. Then you can double check, okay, whether this hydrogen is correct. Yes, hydrogen has two electrons, then that's good. Then you're going to get rid of the paired electron to making a dash. And that is the Lewis structure for water, okay? Well, you can draw the Lewis structure like this. This totally fine, okay? If you draw the Lewis structure like this, that's totally fine. But actually, this structure is more correct than this one. Well, we're not going to talk about the shape of the molecules, but just to let you know, the water molecule is a band molecule, something like that. This is a water molecule. Water molecule is a band. It's not a straight line. It's a band shape like this. Okay, yeah. So when we do the Chem 1, we will talk about this. But just to let you know, doesn't matter which one you write right now, it's all correct. Okay. So let's talk about the one more cases. Okay, this one is a little bit complicated, like a CO. Okay, we talk about, so previous example, those are all have just a single bonds. And then what happens if we have a double bonds? Okay, what happens? So for example, CO, carbon monoxide. So you know this guy, you cannot tell which one is a central atom, which one is a side atom, but you at least you can write it just like this. And then you count how many valence electrons this guy have. So carbon has a 4 valence electron plus oxygen has 6. Totally, they have a 10 valence electrons. So if this guy has a 10 valence electrons, then what do we do? Again, so obviously based on the rule, we need to draw one pair of the dots in between of those elements. And then you're going to assign 8 more to go, okay? So let's go ahead. You can just finish one of the sides. I strongly recommend, in this case, your go ahead to fill one side full, okay? So let's just make the carbon full. Now I have a 4, 6, 8. Then we have 2 more go, 10. So now we already have a 10. Then please don't draw those more. If you draw this structure like this, looks like each of the carbon and the oxygen are all octet. But the point is, you can count how many dots they have. They have 8, 10, 12, 14. So now we have 14 dots. How many dots do we need? We only have 10 dots. So this is not a correct Lewis structure, okay? Because we have actual dots to go. So you should only, since this guy has a 10 valence electron, then you have to draw 10 dots. No more, no less. Then the point is, in this case, only carbon has octet dot. Oxygen only have 4 dots. So it doesn't make sense, right? Then what are you gonna do? In this case, if you're short of the dots, you have to think about, whoa, maybe we need to use the double bonds or triple bonds. Okay, so only this case, if you're short of the electrons, then you do double bonds and triple bonds. So how can we do the double bonds and triple bonds? In general, where you can move one of the lone pair. Remember, lone pair is not shared. Move the lone pairs in the shared area, and then you will see, okay, it becomes something like that. So in this case, this guy share 2 pairs of electrons. And then you double check, carbon has 8 still, but this oxygen have from 4 electrons to 6 electrons. But the point is, it's still not enough. So that means you have to put additional pair of the electrons over there. Then you will see this guy have 3 pairs of the electrons are shared. And this has 2 dots over here and 2 dots over here. So in this case, you will see the carbon will have 8 electrons. and oxygen also will have 8 electrons. So in this case, this is good. Then you're going to get rid of those 3 shared electrons. Then you will write like a carbon, and then they have a triple bonds because we talk about 3 shared electrons. 3 pairs of shared electrons means triple bonds. 2 paired shared electron means double bonds. And then this guy has triple bonds, and then you have 2 dots, single dots over there. Okay, so this is the most important part. Okay, when we talk about the another case, just like a CO2. CO2, the Lewis structure is just carbon in the middle, oxygen on the side. But each of the carbon, those are identical. Actually, they have double bonds on each side. And then you will see this is the Lewis structure for CO2. Sometimes it's hard to see that, but remember this: CO2 has 2 of the single bond, 2 of the double bonds on each side. Okay, so that is the CO2. So this is the CO2, and those molecules is pretty identical. Okay, pretty identical. They have a carbon in the middle, oxygen on the side, and each side has double bonds, and each of the oxygen has 4 electrons in lone pairs. Okay, so the last case I'm going to talk about is the polyatomic ion. Okay, so when we draw the Lewis structure for the polyatomic ion, it's a similar things. Mm-hmm.
The previous one, why did I choose 2 dash?
Huh? Why there's 2 dots?
No.
This one?
Mm-hmm.
Why they cannot have a double bonds, right?
Only 2.
If you have a, I mean, the thing is, if you only have just 2 paired shared electrons over here, it won't work, right? We already, this guy has, in this case, they already have 2 pairs of the shared electrons, but oxygen still not enough dots.
Why not putting the 2 dots on oxygen and 2?
Well, 2 dots on the oxygen is coming from the origin. This is how we assign the dots, right? I don't understand what you're talking about. Are you talking about why the 2 dots over here? Can I put the dots over here?
Why not adding 2 dots on oxygen and remove 2 dots on?
Oh, why you cannot put those 2 dots over here, but from the
2 dots on oxygen and remove the 2 dots on C.
On carbon?
And have 2 dash between them.
You're talking about this. The 2 dots putting over here. Then just draw what you need, okay? I will talk about this later, okay? All right, so the next part, we're going to talk about the Lewis structure for polyatomic ion. So polyatomic ion can also be drawn. For example, you have ammonium ions. This is ammonium ion, okay? Again, ammonium ion, although this guy has a charge, but inside of this is still non-metal plus non-metal. So they are still bonded with the covalent bond, okay? So to draw the Lewis structure is similar, just like draw the compound. You recognize which one is a central atom, which one is a side atom. So nitrogen is central atom, so you put a nitrogen in the here. Hydrogen is on the side, so you put a hydrogen on the side like this. And then what are you gonna do? Then you need to count how many valence electrons this guy has. Well, nitrogen has 5 valence electrons, and the hydrogen has 1 valence electrons, and you times 4. So 5 plus 4, that's 9. Okay, that's 9 valence electrons. But the point is, remember, this guy has a charge over here. They have a positive charge. What that mean for the positive charge? The reason they have a positive charge, that means they lack of 1 electrons. So they have a positive charge, right? If you gain 1 more electron, they gonna have a negative charge. They have a 1 positive charge. That means they are having 1 less of the electrons compared to the valence electron. So totally they have a 9 valence electrons. Since they have 1 positive charge, so you're gonna subtract 1 of the valence electron. So totally this guy has 8 valence electrons. Again, so that is why when we talk about those valence electrons should be the even number for compound or the polyatomic ion. They have to be an even number. If you have an odd number, that's really hard to draw. Okay, yeah. So this guy, so that's why they have to have a positive charge. So if you have 8 electrons, then obviously you're going to assign those parity electrons between the compound, between the each of the elements, then you're done, right? So this is good. For the hydrogen, it's octet. For the nitrogen, nitrogen octet, hydrogen is duet. Then that's great. And then you're just writing the dash. But the point is, this is not done yet. Okay, remember, we have a 1 positive charge. And remember, when we draw the charge, what are we gonna do? You're gonna have a bracket for this Lewis structure and write the charge in the outside. And that is the Lewis structure for the polyatomic ion. Okay, that is a Lewis structure for the polyatomic ion. One more example is just like a CO3, not CO3, okay, NO3 minus nitrate ion. Again, nitrate ion, nitrogen is central, oxygen is on the side, right? So then you need to count how many valence electron for this. Nitrogen has a 5 plus oxygen 6 times 3. Then you have 18 plus 3, that's a 23. 18 plus 5, that's 23. And remember, this guy has 1 negative charge. 1 negative charge means they're gaining 1 of the electrons. So 23 plus 1, and totally they have 24 valence electrons. So that means you need to assign 24 dots. So again, you put those 2 paired, 1 paired electrons between the elements, and then you're going to assign the rest of them. We talk about it's better to fill the central atom full, has 8, and then you go to assign the rest of this. Now we have 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26. And you recognize, wow, if I put if every element follow the octet, we need 26 electrons. How many do we have? We have a 24. So you shouldn't draw the 2 more dots over here. We can only have a 24. But the point is, if you're only at 24, only those 3 elements are octet. This oxygen only has 6. Then what are we gonna do? What do we do in this case? We talk about if you're short of the elements, short of the dots. In this case, what do you need to think about? You need to think about we may have a double bonds and a triple bonds or triple bonds. So in this case, there's only, so for nitrogen, you see, for nitrogen over here, the three of those parts are all shared. Those are all shared electrons. So those electrons cannot move. Only this is an unshared electrons. So they can only put those unshared electrons over here. And then you will recognize they become something like that. So in this case, this oxygen has 8. This oxygen at 8. The nitrogen also 8, and this oxygen got 8. So each of those elements follow the octet, and then let's just move out the shared electrons, and then you will see this guy has a single dash, this guy is single dash, and this guy has the double dash. Okay, that means one of this has a double bond and the other has a single bond. And then you may ask, can I draw the Lewis structure like this? Yeah, you can. You can draw like this, okay? Or you even can draw the double bonds in the top. Doesn't matter, okay? Yeah, those are all the correct Lewis structure. But we haven't done this yet. Remember, they do have a charge. So what are you gonna do? Gonna put a bracket over here and write a negative charge outside. You're gonna put a bracket over here and a negative charge on the outside. Then that's it. Okay, and then that is the Lewis structure for the polyatomic ions. So today we draw quite a lot of the Lewis structures, and we will do the practice. Let's take a break. Okay. And by the way, if you have a chance to turn in the stoichiometry, the practice, and please turn in the practice. So what do you want? No. Well, this one is not a Lewis structure because the carbon here only has 6 electrons. 2 dots means 4. 2 bonds means 4 dots. 4 dots plus 2, that's only 6. So this carbon not follow the Lewis structure. So you can't. Doesn't matter. Okay, so there's only way. If you want to make the Lewis structure correct, you have to put this the unparity, those lone pairs in the shared electron. Then this guy will have it. Okay, so it doesn't work. This you cannot make this. have two worksheets. The first one is electron configuration. The second one is drawing the Lewis structure.